Dear friends, welcome to the channel Total Output Power Solutions. Today we are going to discuss about the heat losses from hot pipes in power plants. The hot pipes are sometimes we find they are non-insulated, and whenever they are insulated, then we are going to discuss about the same in this session. I am Manohar Tatvavadi. My email ID is mtatvavadi@gmail.com. The You can see the mobile number also, and I am from Total Output Power Solutions, Pune. So here we will discuss about the heat loss from the steam or the hot pipes. There are two types of losses from the hot pipes. One is the losses from the uh, there are two losses. So first one is the convection heat loss, and the other one is the radiation heat loss. So these two losses are there. When they combine, we find out the total losses. So total heat loss would be equal to 1 plus 2. We take an example for this. An overhead 25-meter long uninsulated industrial steam pipe of 100 diameter is routed through air at 25 degrees centigrade. Now pressurized steam maintains a pipe surface temperature of 150 degrees centigrade, and the coefficient associated with natural convection is H is equal to 10 watt per meter square per degree Kelvin. The surface emissivity is sigma, which is 0.8. Now we want to calculate what is the total heat loss from the steam line per hour. We calculate it in watts, and if the cost of electricity is rupees 5 per kilowatt hour, calculate the saving in cost per hour if the same pipe is insulated by glass wool and aluminium with a thickness of 50 mm. These two things we have to calculate. So this is the graphical representation of the actual at the site, the actual pipeline. It shows you the insulated as well as non-insulated pipeline. The non-insulated pipeline is length 25 meters, the diameter is 0.1 meter, and the temperature of the pipeline is 150 degrees centigrade of the non-insulated portion. The atmospheric temperature is 25 degrees centigrade. The data as we have seen what is given. So the pipe length is there, pipe diameter has been given, pipe surface temperature is 150 degrees centigrade, that we have converted into Kelvin by adding 273.15. So the pipe surface temperature, then air temperature as well, that has been also converted into Kelvin. The convection heat transfer coefficient H, which is given as 10 watt per meter square per degree Kelvin. The surface emissivity sigma is 0.8, and the cost of electricity, which is given as 5 rupees per kWh. So with this data, we will try to get the calculations done. So the calculations. Now first of all, we calculate the heat loss without insulation. So first of all, we calculate the surface area of the pipe, which is equal to pi d into L. That is the surface area of the pipe. That will be equal to 7.854 meter square. So the convection heat loss, which is given as per the formula QC, is equal to H into AS into TS minus T alpha. So if you put the values, you will get the QC as 10 into 7.854 into the 423.15 minus 298.15. That comes out to be 9817.5 watts. This is the convection heat loss. Then for calculation of radiation heat loss, we use the Stephan-Boltzmann constant rho, which is equal to 5.67.10 to the power minus 8 watt per meter square per Kelvin, degree Kelvin to the power 4. So the formula for that is QR is equal to the rho into sigma into AS into the temperature difference to the power 4. Now substitute the given values. We substitute the given values and the surface area. We find that the radiation heat loss is around 8606.81 watts. The total heat lost without insulation is equal to QC plus QR, that is the convection heat loss plus the QR, that is comes out to be 18.424 kilowatt. We have converted it into kilowatt. The watts has been converted into kilowatt. So the first answer is total energy loss per hour is equal to 66,237.156 kilowatt hours. This is the total energy loss per hour. Now the calculations for heat loss with insulation. It has been now insulated, so we calculate it with insulation. Now the pipe is insulated by glass wool and aluminum with a thickness of 50 mm and surface temperature of the outside aluminum sheet is 45 degrees centigrade. Then the diameter of the pipeline would come to be 0.2 meters. The temperature of the pipe surface would come to be 45 degrees centigrade and the atmospheric temperature would be 25 degrees centigrade. The total surface area we calculate, it will be double, so that comes out to be 15.7 square meter. The temperature, atmospheric temperature and the surface temperature have been converted into Kelvin. So the convection heat loss with the insulation using the same formula that was used in the last calculations, that comes out to be 3140 watts. The radiation heat loss with insulation using the Stephan-Boltzmann constant, that would come out to be 1668.80 watts. So the total heat loss with insulation combined would come to 4808.8 watts, or you can say 4.80 kW. Now the energy loss per hour would be multiplied by 3600, so that would come out to be 37,280 kilowatt hours. So we can calculate the reduction in energy loss per hour, which will be equal to 48,957.516 kilowatt hours. Now the part of savings and conclusion. So the savings in energy per hour would be equal to the energy lost without insulation minus the energy lost with insulation. So that much is the saving. That comes out to be 48,957.516 kilowatt hours per hour. Now if the cost of energy is rupees 5, then the savings in rupees per hour would be come out to be around 2,44,787 rupees per hour. The energy lost we can see is approximately 1/4 of the energy lost because of insulation of bare pipeline. The cost of insulation can be easily justified. If you insulate, the cost can be very easily justified. Now we can take one more example wherein the insulation is just insulation is not there for just 3 meters. Now sometimes the insulation is damaged or removed from the pipeline for maintenance and not put on after the maintenance is over. So the next example is a plant has identified 3 meters of uninsulated 33.4 mm diameter steam piping used for 12 kg per square centimeter and 180 degrees steam. The piping is in service 24 hours a day, 365 days per year. The piping is inside a building and is surrounded by still air at 35 degrees centigrade. So calculate the energy lost due to the non-insulated portion of the steam pipe and the cost of energy lost per year. This is the example. Now you can see the graphical representation of the example. Now herein we have taken the there is a 12 kg per square centimeter steam with 180 degrees centigrade. We assume that the temperature of the outer temperature of the pipe without insulation is also equal to the steam temperature, that is 180 degrees centigrade. So you see the steam bare pipe, the insulation is not there for 3 meters. So we want to calculate the heat loss due to convection and radiation because of the non-insulation of pipe. So we calculate it with both ways. So before we go into the calculations, let me remind you for uh, to give your comments and like, share and subscribe the channel Total Output Power Solutions. So the calculations are, without we calculate first of all the heat lost without insulation. The surface area of the pipe, AS surface area, is equal to 3.14 into 0.334, that is diameter, and into the length, that is 3, that comes out to be 0.3146 square meters. Hot pipe temperature Ts is 180 degrees centigrade and the ambient temperature is 35 degrees centigrade. So the convection heat loss, we use the same formula as we have used it before. So we put the values and the convection heat loss comes out to be 387.744 watts. Now we calculate the radiation heat loss. Again we use the same Stephen-Boltzmann constant and the same formula for calculation of radiation heat loss. The emissivity of the surface, we take it as point sigma, that we take it as 0.8, and we calculate the radiation heat loss using the same formula. So Ts and Ta has been converted into degrees Kelvin and substitute the given values of the surface area. The radiation heat loss comes out to be around 300 and it comes out to be around 331.11. So the total heat lost without insulation would be QR plus QC, which would come to 718.859 watts. So the total energy loss per hour would be, we converted into kW, is 0.718 and 859 into 3600. So that comes out to be 2588.4 kilowatt hour. The total monetary loss per hour would be 12,942 rupees per hour. So the answers are ready here. The total monetary loss would be per year would be around 11 crores 64 lakhs and 78,000. This much would be the total monetary loss per year without insulation. Now we calculate the losses with insulation. So after providing insulation, glass wool and aluminum sheet, the data is outside diameter comes out to be 0.0668 meters. Area you can calculate. The temperature of the outer aluminum sheet is 37 degrees centigrade as per the data. The convection heat loss we calculate putting the values in the formula that we have used. It comes out to be mere 10.70 watts. The radiation heat loss, again we use the same Stephen-Boltzmann constant and the same formula. The emissivity is also, we take it as 0.8. So it comes out to be only 6.73 watts, the radiation heat loss. So the total heat lost with insulation would come to around only 0.01743 kilowatt, and the total energy lost per hour with insulation would be multiply by 3600, that would be 62.75 kilowatt hours per hour. So yearly monetary savings, as it has been already asked, yearly monetary savings and insulation cost. So the heat energy lost per hour with insulation is 62.75 kilowatt hours, as we have already calculated. The cost of energy is rupees 5 per kWh. So it comes out to be the cost of energy lost, that would be 313.75 rupees per hour. Now money saved because of insulation. Here it is interesting. The money lost because of the non-insulation is 12,942 rupees per hour, and whereas the money lost because of the insulation is only 313.75. So you have a saving of money saved is as 12,628 rupees per hour. So you can calculate it for per day. It will come to as we have calculated it, 30,300 3 lakhs 3,072 rupees per day. The So you can calculate it annually also. It will be 11 crores 6 lakhs 22,375 rupees per year. And the now we talk about the cost of insulation. The cost of insulation at the max, it is around rupees 600 per meter square. Now this will includes the labor and any other costs such as outages and etc. that you will require. So we calculate the area of insulation is only just 3 meters, means the total area would come to be around 0.629 for 3 meters length. So the cost of insulation would be mere around rupees 377.40, and the life of insulation would be around 10 years. So it is the insulation cost now mentioned here are only typical. Actual may vary, but not to a great extent. So this would be the insulation cost. So it is the conclusions we can say here. In any case, insulating the hot pipes is always economical. The uninsulated hot pipes, they contribute to the hot environment. The insulation of hot pipes is also necessary from the point of view of safety of personnel, because if somebody touches it, there may be a severe burning or something like that. So a accident may be there. The hot environment, because of uninsulated pipes, hot pipes, may also lead to malfunctioning of control and instrumentation associated with on the particular floor, or you can say particular environment. The non-insulation of hot pipes increases the load of air conditioning. The overall heat rate of the plant also increases due to the hot non-uninsulated pipes. Now, after proper insulation of hot pipings, there will be decrease in CO2 emissions. This point is also important, which may be noted. With all this, it is always recommended to insulate the hot pipes as early as possible. So friends, thanks for watching. Request you to please comment on this. You like, share and subscribe our channel Total Output Power Solutions. With this, I take your leave. Manohar Tattwavadi from Total Output Power Solutions, Balewadi, Pune. Thanks for watching.